All right. We are back working on the game and everything around it and stuff like that. And today I wanted to work on the image loader. I can't see myself. I also got a new microphone. If you couldn't tell, if you weren't here last stream was sort of a disaster. Hipster dev, thank you. Thank you. Anyways, last stream was a friggin' disaster because my mic died, and it turns out my mic didn't die, and like I used the webcam mic for like 2 hours, which was very fun. So we didn't get that much done, but now I am currently working on, in order to be able to embed the tile sheet that we want to have in the file format of the tile editor and read that back to the game and stuff like that, we need to actually be able to write the data somewhere, which I haven't implemented yet, which is quite funny. I only wrote the image loader side of that library. So, yeah, let's see. I think first of all, I'll make myself a little bit louder. Make the compressor less aggressive, and then slide myself back a little bit like that. Okay. So, we're gonna have to, validate all this and then make sure, like, this is the only instance where I really actually use unit testing. Because, I mean, can't have pixels be wrong. So we have a file pointer and we have a data pointer, and we want to write the data to the file in QOI, right? So we have the width and height. So our naive loob would be like 4. And then actually this needs to just be width, right? So naively, we go over every single pixel that exists and sort of write it. And then we could actually just make a valid QOI image by literally just doing that. But that's not the point of this format, right? The point of this format is to actually, let me sort of hang this here somewhere. Maybe like that. And then we can, well, I don't know if that's really legible, but we can sort of zoom into what's relevant right now. We could just implement this bit by bit, and I'm thinking, right? Because we have a valid QOI image if we literally just show each pixel, but then, we'd need not just 4, but 5 bytes for every single pixel, because this house has transparency, right? Or at least the stuff that I work with has transparency. So that's the big question, is how to write an encoder. Because decoding is easy, right? You just read what is there and you sort of decide what is what tag. But then deciding what op to use in the encoder is difficult. I think we want to just do the naive thing and then use RLE for now. And I also have to go out of resizing mode. I don't know why I kept being in resize mode. Because RLE would certainly be the easiest thing to implement, right? Because we have a pixel, and we initialize it as 000255 because possibly we don't even have alpha to deal with. And then, yeah, we need to fread. And how much do we fread, and what do we check it against? So we always want to check fread against the number of elements, which would in this case be, would it be a certain amount of bytes, and byte be the element, or would it just be 1 pixel that is like 3? I guess I'll just do this. And then we want this not equals 1, or I guess I think this is, so size and then n. So we want channel count, and then we want one of these, and then if Oh Lord, how do you do these f reads? Maybe it would be good to go back to, just for a second, because I use them here, f read. So how many parentheses? So 2 here, and then, yeah, and then this is closed there. So, and then this is just a size t. Okay, perfect. Oops, exit. If code, I guess, or elements, and then we just want a size t elements equals 0. Although we have code anyways, so just rename this. And why don't you like this? Oh, because fread, yeah, fread doesn't have actual. You want to write at current pixel, right? But no. So I think we need to go byte by byte. Do we? I'm thinking, what is the easiest thing to do here? Because possibly, we don't know if we have RGBA or BGRA data, right? So channels could be flipped and we're none the wiser. And I'm also gonna go and check my levels real quick, and that just means listening to myself. Hello? Hello? Hello. Okay, that sounds pretty good. So what do we have? We get the format, so we know what format we're in, but if we want to read a pixel back, I guess we just leave it and we define, you know, BGRA or whatever order. Now the question is, whoops. The question is, am I allowing like ARGB? You know what I mean? And I don't actually know the answer, and the answer is right now, no. Right now I just allow RGB, BGR, BGRA, RGBA. And I think that covers about everybody's uses. Right, I just want to go back to here. Low. Where are we? Where's the big to do? What? Oh, it said right QI. It's right here. Read channel count amount of bytes. No, we'll just, yeah. Because if we fread into current pixel, right? So we want one size of, no, we want channel count. And that's how many bytes from file. And what is wrong? It's like this, isn't it? Elements. And that closes that one. No, that closes this one. There we go. I always get these parentheses wrong because they're so confusing. So this is our fread. And we fread channel count amount of pixels. And the thing is, if we read 3, then 255 does not get overwritten. So that's correct. And if we read 4, then it does. So I don't think I need to change this for RGB, BGR, whatever. And then we know what we have via the format that is passed in. But so this needs to be handled, right? So stood error, and then we want, I guess, some sort of error message. Failed to read pixel. Yeah. Do we need to be f-reading, f-writing the entire time? I don't know why I'm f-reading if I just have the data. I mean, I guess I could, but like, There is no EOF right there. So this F reading probably doesn't really make sense. Because we're not reading from a file, right? We are just reading from a pointer. Hey, SQF Ayush, how you doing? I don't think I want to use fread. So I'll just... The thing is, we need to trust then that whatever is passed in here, like the data is actually as big as width and height. But I mean, you kind of expect this behavior from an image loader, right? If you tell an image loader to read from an image and the image is like 10 by 10 and you tell it to read 100 pixels, I mean, that's completely undefined behavior, so that's kind of on you. So that's what I'll leave it right now. It's the easier solution for me, is to just say, we are already like in the pixel, so do we want to have an index, or do we just want to increment x like plus equals? Because this is going to make it weird. Sub to you from the Gentoo video. Try to install, became mad. That, I mean, yeah. That can totally happen. So the thing is, how do I use the pointer here in the safest way? Do I convert it? No, it probably doesn't make sense. I just do, I guess I do a loop in a loop in a loop, you know what I mean? Or I mean, nah, so if channel count is 4, it's the stupidest way I know how to do it. And then that's conditional, right? And the other ones are not. So red. Yeah, so this is, I think this is exactly how I did it in reading back. So you set the red, which is based on format being image surf. Oops. Is it not format? Is it channels here? Channels. And then I probably want to make this a sort of bool, right? So bool flip, I think this is exactly what I called it, flip R&B, flip red and blue, not R&B, the music. This needs to be channels, BGR, or, so this is format equals, right? Or format equals, image surf, channels, BGR A. And then we have another one, which is just, do I need that? I think I have another one, which is like ignore alpha or something, but like I don't need that flag if I just can just check for channel count equals 4, you know? But I guess just to show that it's invariant, ignore alpha, sure. Is format equals, whoops, that is not what I wanted. I was holding one key too many. We want RGB or format BGR. Okay, so now we know whether we should flip the red and blue channels and or ignore alpha, right? So if not ignore alpha, is that if I think I want to inverse the flag, right? And I sort of, oops, that's not what I wanted. I sort of just want to call it like, I don't know, use alpha, use alpha. Oops. Makes it easier because if not ignore is just harder to read than if use. Alpha is flip R&B. And if that's true, then we have the blue value. And if not, we have the red value. And the blue value would be data. This is always the big question as well, is do I increment the data pointer or do I just index into it as if it was an array? And the answer is I don't know. So depending on how big the data gets, I can't use an UN64 to index into it, so shouldn't be too big of an issue. And like, I don't think it's going to make much of a difference in the runtime. And writing is, I mean, we all know writing is going to be slow anyway, or slower anyways. So let's say that we want to just increment the data pointer, which I think I can do here, right? Plus data or some shit. But data is uint8 pointer, so data needs to also be plus equals channel count, and then x does not matter in this sense, so we could just increment x. So we increment y, we increment x, and we increment data by channel count, right? So we go, okay, so we know where we are by just using the data pointer. And then sort of data plus anything. So first value is going to be R or B, so R by default, but if flip R and B, then the data is +2, and if not, it's just whatever's at data. uint8t, what is the issue? Fix available? Okay, well, tell me your fix. Oh, no. Am I dereferencing wrong? Oh yeah, here. I'm not dereferencing here. So this works, right? So because we're at the very first value of the very first pixel, and if you want to flip them, then we just go 2 over. If not, we stay at the same place. And then we can say green, that doesn't matter. That is always going to be data +1. And then we can say blue, and that again depends on flip R and B, and whether that is, if it's true, it's just data, and if it's not, then it's data +2, right? It's just the inverse from the other one. So let's sort of, well, this is a little confusing. How'd I do it with the other one? Green. I did it okay, I guess from the previous pixel, yeah. That is a lot more legible than all these like data stuff. I don't know if I want to move it all the way out there and just make it even less legible. I think this is okay. So we have the current pixel red, green, and blue. And if, and only if, we have alpha, then the alpha gets changed and it becomes just data +3. Because alpha will always be at the end if it is present. And I don't really want to deal with moving the alpha to the front. So yeah, that's that. Now if, I guess if current pixel, can I just, can you, I don't think you can. No, because that's like a, yeah. This is the only time C++ would be sort of very helpful to override the operators or overload them. But I guess, you know, I can just give current pixel dot red equals previous pixel dot red, and it's sort of nice to see the comparisons in this case. And current pixel dot green equals previous pixel dot green. And then I think I'll move sort of here and then just do current pixel dot blue, prev pixel dot blue. And I need an ampersand here, of course. And cur pixel, whoops. No, that's not what I wanted. Sort of just wanted to align these. Alpha, oops. Then these are the same pixel, right? So cur red, prev red, cur green, cur blue, prev blue, cur alpha. I'm just looking to see if I didn't make any typos. So if they are indeed the same pixel, then we can just, we want to RLE, right? There is another way, right? So there's QOI up run, which is just a tag, and then you say how long, and then you just take the previous pixel and then run up to 62 times. But there is also, yeah, QOI up index, which is an index into previously seen values. But that is exactly as expensive, because that's 1 byte, as just saying run of length 1. So yeah, you can say run of length 1, and I'd rather do that because it's easier to think about. So as soon as I see the pixel being the same as the previous pixel, I start a run, and then I sort of store the length of that run, and that's all I store. So right, and then else we don't we have to evaluate I guess in order of cost of storing. So can we do a diff, right? Try in order. Then what's the other? So if we can't do an index, I guess index is the first thing, right? Because is the probability, I don't know. I think diff is better than index. They're both a byte long, but diff will probably just, I have no idea. Like, just from speculation, I couldn't know whether accessing a random element in some array somewhere in the decoder is going to be faster than just taking a diff, which are like 3 or 4 calculations, but granted, that is very fast. So we definitely do not want a Luma. Luma is 2 bytes. So Luma is like our last option. I mean, no, the last options are RGB and then RGBA, right? But so we try in order. We tried run, QI up run, and run is the best thing. And the second best thing is diff. The third best thing is index. So run the index, we still missing Luma, which is just 2 bytes, right? So QI up Luma is still preferable to then doing QI up RGB or QI up RGBA. Okay. And these all have conditions, right? So diff is only possible if the differences, oh lord. The green channel is used to indicate the dynamic direction of encoding 6 bits. If we can encode this thing in 6 bits, right? No, this is Luma. Hold on, this is diff, right? So red channel difference, green channel difference, and blue channel difference. So this is else if whatever, then we want diff. And then else if we want the index, and then if these are all possible, and then, you know, worst case, we store the entire thing. Depending on channel count. I want to add to do to all these. To do. Fwrite automatically advances the pointer for us, so we don't need to worry about that. We're past the header, so we're at the beginning of the stream. And this is the loop, so we end here. Write QOI end of stream marker, which if I recall correctly is just 7 bytes of 0. 7 here. It's 7 times OX00 plus OX01. So yeah, we can just write that, which is a 60. It's just depending on the endianness, right? This is 1, or sort of very close to the UN64 max, right? But it's 1 in UN64 form and or the latter or the former. But hey. So we can't do a run. We're here. We have to do a diff, or we're trying to do a diff at least. And we need to see whether we can. And the diff needs to be... Oh Lord, that's a lot of checking. So... if cur... it is, which way is it? I think it's current pixel minus previous pixel, right? Or is it previous pixel minus current? No, right? Yeah, okay, it says it right here. I wasn't looking. So they are using wraparound, but I can just use U and 8Ts, right? I said that's a lot to check in like one condition though. But I guess I can just make it like this. Cur pixel and then prev pixel. Do I pass pixels on the stack? Probably not. They're fairly big to be passed on the stack. Are they? No, they're just... Since they're UN8Ts, this is like, they're just a UN64T, so I'll pass them on the stack. Doesn't matter. If check diffs, if check QOI diff, I'll sort of make it like this, so it's sort of legible. And then just above here, it's going to be internal, oops, check QOI diff of pixel, cur pixel and pixel, prev pixel passed on the stack. And this is, I guess, a bool. Is this going to be... Maybe I want to reuse this, but maybe also not. Because I could return a pixel here with all the pixels being the differences, like a delta pixel. But I think that's just more complicated than just checking for each. I'll just check for each op like this. Check QOI op diff. Right, that's very legible. So we pass 2 pixels and I need a comma here. So if, I guess the easiest way is to just check the negative cases, right? So if we want the difference from the red, We want the difference from the green, we want the difference from the blue, and we want the difference from the alpha. Do we care? No, we don't, right? We assume the alpha is the same, right? So if cur pixel dot alpha not equals prev pixel dot alpha. I don't know why I'm getting all the freaking stud recommendations. Like my LSP just doesn't know that I'm just using C. But maybe I can tell it in a second here. Then return false. Right? And so return all the other falses. And then I'll store the differences in UNATs and then they can wrap around correctly. So what are you... Is it not? I don't want compile commands.json. I want compile flags. So I just have include. I think I can define the standard. Playing D define standard of C. Here. So it's dash std equals. I think I can just say C99. And then it won't give me the stupid recommendations anymore for prev. Okay, thank you. I think that solved it. But then also, expected expression. Yeah, that's fine. So where's the definition for this? Because it's just verify path. It's just in the header. It's in Linux platform. Oh, but we're here, so it's not. Why is it? No. Do these take different? No, they don't, right? Why are these in two different headers? Okay, I need to fix this first. This is some weird shit going on here. All right, fella, how you doing? Why are these defined in here? I mean, the externs, like this, these shouldn't exist. And this should be in the, whoops, where are we? Include in the main header. And that way I can use it there. I'll just do like this. Where's the other one? Win32, get away. And then these are just, those are just sort of empty now. But now I can go back and no more errors. Okay. So LSP fixed. How you doing, Alfie? Alfie Siddons? I think I got that right. Okay, so if the alpha is not the same, we can't sort of do this, right? Because this is just the difference of the red, green, and blues. And we suppose that the alpha is the same. So this is going to be current pixel dot red minus prev pixel dot red. And these are going to be sort of the same thing. Oh my god, that's not what I wanted to do at all. I don't know what that was. There, sort of just wanted to paste that. Maybe that would have been faster to type, but who knows. I'm good, man. What's this project? Currently, this is an image sort of loader and writer because I am writing a 2D game from complete scratch. So let me just do this and then set this to blue. And then I can show you real quick. So I don't have much right now. Let me just, sure, let's move this to like 7 and let's go to 7. So this is the little game, right? So we run the game. It's literally just a dude running around. That's it. But yeah, I'm building everything. I'm building the engine, right? So if you go to the engine, there's a bunch of code for like composite, you know, like compositing, scaling, loading the image, sort of indexing into, well, the tile sheet is more on the game side. Basically, I'm doing everything. right? Every little part of it needs to work. And the big part of what it needs to work is sort of, hold on. Right now I'm working on the tile editor. It's not compiling because I have a bunch of non-compiling code in here. In ImageServe, okay. Hold on a second. So I'll just sort of do this. And then it should, whoops, that's my editing software. That was not intended. And then we're here. We want to be here. It's a little convoluted, but here's a tile editor. You can sort of select your tiles, you can place them, whatever you want. You can sort of do like as small or as big as you want, kind of. And then you save this, and then you would load it into the game. And that's the part where I'm at right now. Saving and loading, sort of defining the file structure of that file. And more specifically, I'm working on a way to save the image, right? And then embed that into the tile sheet sort of image. So the game could just look at one file, and the file contains which tiles are where and where they come from, like in the tile sheet image. Does it for the love of the game? I do, man. I legitimately do. I love this like sort of very low level stuff. Like this is an image format right here. And this is very simple. It's basically PNG, but simplified a lot, right? And also I just realized I didn't copy the link for YouTube chat. So hold on, you are getting scammed right now. And I will rectify that. Boop, boop, something went wrong. No, it didn't. Boop, there you go. Okay. Thank you for texting so I could realize. Anyways, I think, what looks better, this or this? I think this looks, oh no, that looks pretty bad. I'll leave it over there. Is it mostly C? It is completely C. The only stuff that is not C, like if we do include and source right here, for example, is literally just the Lua for the pre-make, for building it, and sort of the PowerShell and the bash scripts for building it on the different platforms. That is it. It's all C. I mean, this is about 800 lines. I'm guessing like the engine and the engine game and stuff like that is probably about like 2,000 lines each, if I'd have to guess. So where we are, where the engine is 1,500 lines because I simplified a bunch. And then like source include, the editor is 1,200 lines, and then I'm guessing the game is around there as well. But back to topic at hand. We're here. Okay, yeah, so we want to check whether we can do the diff operation. The decoding is sort of easy, right? Because you just look at this, you look at every byte, and every byte has like a code that tells you what the operation should be, and then you perform that, and then you're like, hey, this pixel is, the R value is too bigger than the last one, and then you just take a difference of that pixel. Encoding is sort of more difficult, which is what I'm currently doing, because I need to figure out what's the most optimal way to encode. So that's what we're currently doing. We're trying to make an encoder that complies with the specs so I can both save and load in this format, because I can already load. All of what you're seeing is loaded in QOI on this format. But yeah, it's all C. It's I just like C. C is very simple. It makes me think about stuff the simple way. I mean, just for example, here, right? Well, even though I could probably extract this to a function, it's really easy to see what this is. And it's literally just this, you know, if current pixel equals prev pixel. But you can't do this in C. It's not permitted because pixel in this case is a struct that I defined. And you cannot just say like, hey, is this struct the same as the other one? Because the compiler doesn't know what to do. And like in C++, you can do this because you can overload what it means to be equal or not. But I personally like to see this and or a function where this is, you know, the code, because this is what it's doing. You can do all your C++ isms and whatever, but at the end of the day, you're doing these for comparisons. So I like to see what ultimately is going to be, you know, what assembly is going to be emitted in this case. You just recommended this live and I have no idea what's going on. New to programming. Okay, well, we're making a game at the end of the day. Just think about this as building a car, but I sort of have to build the factory I have to build the resource acquisition for the metals and absolutely every little part of it. That's sort of how we're not building a car, we're building a game, but this is sort of how this is. I'm used to higher languages like Java, C++, and C#, where comparing objects is incredibly easy. Yeah, I mean, the Java way is, personally, I like it even less, because usually what you would have is, this would be a class, and then you would say equals, and you would always have to call it from the class, and then that, right? But you have to sort of implement this yourself as well. At the end of the day, there's some function somewhere that's comparing these values, right? And whether that is like after 7 layers of abstraction or literally just, hey, here's the 4 checks. You know, that's just, I prefer this personally. So what we want to do is we want to write these checks for the other ones as well. So if we can check sort of QOI op, what is this is index of current pixel. And I think I don't need to pass the previous pixel here, but I guess we'll see about that. And then we want to check QOI op, I guess Luma, right? And then worst case, we just literally naively store over here the RGB or RGBA values, right? So, and this depends on the channel count. Yeah, okay. So let me do index and Luma, yes, okay. So diff, and we can just kind of sort of check this and just do this. Index, and then let's say Luma. But for Luma, I probably have to pass both, so let's do that. But how are your, my parents are proud of you, bro. Thank you. How are your first experiences with programming? What's your name? Jay Sing. I can't even tell which are the different words in there. VJ. Can I call you VJ? That sounds kind of cool. So what happens if that struct gets more values? You have to go through all of the references to it and fix them. What do you mean gets more values? No, I mean, technically, but we're literally just talking about a pixel. It's a struct that literally just stores red, green, blue, alpha. The definition of a pixel is not going to change tomorrow. That's sort of the thing that we write on here is a pixel is still a pixel. VJ Sing. Oh, I see. I was sort of thinking about like Chinese names, and that was totally confusing me because I've never seen sort of that. But that makes a lot more sense. So Vijay or VJ, whatever you. VJ sounds kind of cool. I'm not gonna lie, it's a cool name. Anyways, so we'll do these later. Check index and check Luma. But right now we want to check whether we can do the diff operation. Diff. So the diff operation supposes that these and they're stored with a bias of 2. Okay, so I think I have to think about that. Ignore me, man. Brain fart. No worries. What? I didn't know you could do this. Okay, that's kind of cool. You can just do this in LibreWolf. That's sick. The pixel could be compared in one check if you checked as a UN32T instead of UN8T. Yes and no. I mean, I would have to extract no. So I would have to extract the differences anyway. For this one, yes. I mean, if I just cast them, yes. I guess so. I don't know if C like casts allow you to do that. But we could see real quick. Get the pun. So if UN32T pref pixel equals UN32T current pixel. Yeah, no. It's not going to allow you to cast it like that. Like I would have to extract the values. And personally, just right now. But sort of the C++ casts would, sure, they would allow you to do that. I could take a pointer to the pixel and then cast that pointer to uint32 pointer and then dereference of that pointer, but at the like, I think that's even more arithmetic than just this. Today I installed Mint Linux and now I'm going back to Windows. Hard to learn Linux and Java together. I see. Yeah, you know, one step at a time, I guess. I switched to Linux in August of last year and I don't want to look back. So that's just my experience. So current pixel and prep pixel, right? We probably need both to check Luma. We'll see. Take it step by step. I've only just started messing with Linux to host my web dev projects. You don't need Linux to learn to code. No, you don't. I mean, it's you know, if you want to sort of go cold turkey, by all means, it does help. And there's a greater, I think, overlap between the percentage of people who use Linux and are programmers or know stuff about programming. And also getting used to the command line is really nice. You know, doing, and Linux has so many cool things for programmers or anybody who uses computers and shit. And there's a lot of, I don't know, there's a lot of cool stuff. Like, I love nproc. It's just like, you know, instead of stuff like that, instead of going into like, oh, Windows R, MS Info 32, where's my thread? No, that's my core count. But then I need to, and then it's like, just, you know, Linux is just like, yeah, just one command. Too cool and get versed with. Yeah, it's very useful. I mean, scripting, even in Windows, scripting is great. Like back when I was using Windows, and Windows sucks in the sense that it sort of corrupts itself sometimes. So I used to reinstall Windows a lot. So I wrote a PowerShell script that would sort of get all my configs from my GitHub and get a list of packages that I want to install and just install them all automatically. So that when I newly install Windows, I just hit a button and then just the entire computer sort of sets itself up for me. And then I wrote PowerShell for like all sorts of things before I realized that that's kind of just a Linux way of doing things. So I switched to Linux. That's the TLDR of why I'm here on Linux. And I just like it. That's cheeky. Yeah, it's I haven't bothered to write it for Bash, like translate it. But it's like, I don't know. I don't need it that much for Bash because it's already pretty fast. You just like, you get a package manager that you want, or just run with the default one and just, you know, sort of get all the packages. On Windows, there's more stuff to do. Like, you know, PowerShell 7 doesn't come with Windows and you need to upgrade to PowerShell 7 and and plus getting all the stuff that you want is much harder on Windows because it usually involves you going to the website and clicking the download button, then running the installer instead of just running it through the command line. But yeah, so if DR, what will we get? Right, so let's think about this. 1 minus 2 will result in 255. I don't want to store this in a uint80, I don't think. Do I? But I kind of do. I need these to wrap around the exact correct way, and they do behave like a uint80, I think. Good luck for your game. I'm going to have homework. You inspire me a lot. I want to be pro dev like you in the future. You deserve myself. Thank you. That means a lot, VJ. But I don't get paid to do this. I mean, I get paid to code other stuff at work, but it's a lot more boring than this. But yeah, that's a nice message. Thank you. So, whoops. What will this be? If current pixel, let's say we have, I can't type today. If we have a value of 250, let's say 250, and then 255, it just becomes -5. In -5 in the world of a uint8t. See, this is the really cheeky thing that we got to think about, because if we get this wrong, the image will look completely messed up. You know what I mean? But the good thing is we already have the correct. It's not encoded the same way. We'll see how this goes, because it would be really good to validate against like this is the actual correct way to sort of store these. But I don't think there is one, because you could also, you know, you can make index calls of 1, and then you can make run calls of 1, which are the same. They're the same length, they're 1 byte, they're the same efficiency, but they are different. So encoders may choose to do one over the other, but no two images can be encoded this. I mean, they can be encoded the same, but they don't have to, if that makes sense. And then these need to be, I guess, they all need to be -2 here, I think. BIOS is stored as untitled integers with a BIOS of 30. No, this is the other one. This is Luma. Here, we're just talking about this. The difference in the current channel BIOS are using wraparound operations. 1 -2 was 250. 1 -2 is a difference of 255. So this is correct. Okay. So I want them to behave like normal, right? So if DR is bigger than 3, how many 2-bit, because we have we have 1 and then we have 3, so yeah, we can't store 4, right? Because this is 4. This is 1, 2, 4. We have 2 bits per. So if any of these are bigger than 3, or DB bigger than 3, then we can't. You know, we got to return false here. We cannot encode this as. Do we have another check? Or I think this is all the checks, right? But then having to, I'll have to recalculate these differences anyway, I guess. But that's fine, right? It's a little inefficient. Do I care about that little inefficiency? Because I'm checking here and I'm doing the difference, and then if that is true, then I can do the difference again. That's fine. I don't care that much. But yeah, so I guess we can just return. We don't need to, we can just do this and change all the, whoops, change, hello. I cannot use this thing today. So we want to change, we want to look for these, and we want to change them to these, hello. And we want to do this globally. So there you go. Would have been probably faster to do that manually. But here, so we check for the current pixel, previous pixel. If the alpha is not the same, then we return false. Otherwise, we check all the differences. And if any of the differences are bigger than 3, then we return false. We return true if only if these are all smaller than. See, this is why sometimes, sometimes you might want to go through stuff verbally. Just to make sure you're making the right thing. So smaller than 3, and this smaller than 3, and this smaller than 3. Perfect. So now we know we can do a diff, right? And we do the diff by saying, there's an fwrite call here somewhere, right? I guess dr, and it's just this, it's just the same shit again, which I could return. And I probably should, but who gives a shit? There's gonna be like milliseconds of difference, if anything. It's just sort of a better flow if I check if it's possible, and if it's possible, then we do it. So these are all smaller than 3, right? But then we have to sort of offset them. But No, we don't, right? Because we do that when we read it back. We do that when we decode. So yeah, we just store 0 to 3, I guess. Yeah, we store 0 to 3. So either 0, 0, 0, 1, 1, 0, or 1, 1 for each, which are the differences from 0, 1, 2, 3. And then when decoding, you do the -2. So yeah, we just f-write these. We f-write... Oh god, there's some bit shifting involved here, I think. We f-write... I guess I'll store these into not a... So the byte that we want to write is sort of... It's going to be dr. No, yes, no. It's going to be db. Yeah. Bitwise OR with DG. And that needs to be shifted left 2, right? And that needs to be shifted left 4. And this needs to be 0, 1, which is, so, right, we have 1, 2, 4, 8, 16, 32, 64. Really? 128? Yes, 64. That is a 64-bit. Oops. Yeah, your bitwise OR. So this should actually be correct, right? It should be blue is at the end, and then green is shifted up by 2, and then red is shifted up by 4, and then 64, which is just 1 bit. And I think this will evaluate to the correct thing, but we should probably verify that. To do verify. But I guess we'll verify all of the ops here. To do verify all of the ops manually with like a test image maybe, because that'd be probably the easiest thing. So and then we f-write, and if that was unsuccessful, then we say we print the error, right? We say std error, and then we say what we want. Whoops. I can always just take it from here and say whoops dot up hello. What? There we go. Failed to write. Failed at QI op diff. To write. There we go. If elements equals f-write not equals 1. Yeah, okay. So 1 file, I think. Okay, let me think, and then data. No, this is where we want to write to, and we want to write from data. To parameter of type file. Hold on, which one is the freaking destination? So this is where we write to. Is it? This is where we write from? I think this is where we write to. So that's sort of incorrect. Pointer, size, and I think S is source. Let me go to my other f-write calls for a sec. because I am really confused. So yeah, this is where we write to, and this is where we write from. Failed to write header to save file. No, other way. This is where we write from, or what? This is confusing. Yeah. Yeah, we want to write to the file. Yeah, so where from to where to. Makes sense. So we write to the, do we write to the file? Yeah, we write to the file. So data. No, we want to write from byte. If this is not equal 1, where are my parentheses again? What? Oh, there was a missing semicolon there. And then we probably want to, yeah, to do return error code. We want to return error codes and just move them with the chain. But so I think this is pretty straightforward. And then QI up run just means we want to write a single byte, and that byte will be, it will be 128 plus 64, right? Which is what? That's 188 and then 172. Is that correct? That looks correct. 172 in binary. To have to fucking Google that. Yeah, sure. I think that was, no, that doesn't look right. What? That's 128 plus 64. Right, which is 188. 192, of course. What am I talking about? I don't know what went down. See, head math. Sometimes head math's not good. So it's 182, and then the amount of run. So it's run length. So we want to save run length. And then sort of if it's, yeah. Okay, note run length can't be bigger than 62. So that's the maximum. To do get run length can't be bigger than 62. It's sort of hard to read this, but binary literals are like a C23 extension, so I don't really care about that. And then, yeah, failed to write at QOI run, because we write a single byte here. And then for index, it's the same shit for index, right? We did write a single byte. Yeah, and it is just 0 and whatever the index is. And the index, no, it's not index, it's image surf QOI index. I always get confused. But is it the current one? That's the big question with this index. Do we, because we index with the previous pixel. Each pixel is seen by the encoder if the pixel value thinks matches the current pixel. No, we can't return this one. We just sort of return an index. We need to find whatever that index is. And it's literally just the index. So we don't have to save it in a different one. We can just say index and index find index can't be bigger than HJP. Bigger, hello, can I type? Than, which is also like 64, right? Or 62? Because we have the 6 bits. Yeah, 63. Okay. We just have all of those available to us. So we say, we just write the index because the tag is 00. 0. Yeah, okay. And then we need to check whether we can write that out from the index. For the check QI op index, we need to pass the array of scene pixels. We need to, whoops, where are we? Current pixel and pixel pointer scene pixels. And let's pass it down here as well. Add prev, no, scene pixels. Incompatible to passing pixel. Okay, struct pixel to a pixel pointer. What? Because that is a fixed size. What do you want? Can I just... Can I say that? I guess I can. No? No, I cannot. But I can just, yeah, I can just pass it like that. So that works. Okay. Check if pixel has appeared in array. I don't know why I typed all that out. I can just do it myself without waiting for that. But I oh, my throat is becoming very dry. Okay, we need to loop. Do we need to loop through all the pixels? I guess so. Well, that's annoying. Is there a smarter way to check? And running array of previously seen pixel values is maintained by the encoder and decoder. Each pixel that is seen by the encoder is put into this array, formed at the hash function of the call value. In the encoder, if the pixel value at the index matches the current pixel, this index position is written to the stream as QI op index. Yeah, we don't care about the hash function in the encoder, do we? No. Yes. Yes, we do, but we only care about it at the end. So here, scene pixels at image of QI index is current pixel, right? Over here, we don't care about this sort of hash function, because all we need to say is, have we seen these pixels somewhere before? I guess we can, but it would be nowhere else, right? So let me go to that macro. I guess I can rename the macro and make it sort of easier to use as well, but it's red, green, blue, blah, blah, blah. Okay. But if it was going to be anywhere, it can only be at this hash function, right? So we only need to check whether this pixel is whatever's currently lying there at that. Does that make sense? Does it make sense? No, I think we just check for it anywhere. I am very confused. Because what do we want to do? We want to write to the stream, and we want to say, hey, just index to this index. Like, find the pixel in the array, and the pixel is definitely in the array. A decoder, yeah, whatever. Can we look at the reference encoder? I would like to. What? Where's the converts begin between ping and QE? Sure, but where is your code? Bench? Is it in here? No. Where is your code? QI.h. No. File extension, limitations, tools, implementations. I guess, yeah, sure. Streaming decoder, that makes... No, I want an encoder though. Encoder and C99. Hey, there we go. What? Just ink? It's just in one header or what? Okay. Oh, there's a lot of inline stuff. Right QI header. Blah, blah, blah. I literally just want to see how you do this one thing. Oh. Yeah, this is some... Sure, this is a choice. It's very Java-like code. I think you just pasted the entire specification into comments and then just implemented from that way. Sure. Luma, diff, index. What? Get and seek the position of the buffer from the QI file. Tag and QI tag mask. What are you talking about? No, enc. Oh, enc and dec are encoding and decoding. I see. So we want enc index. What? Place the index position of the buffer into the QI file. Yeah, but when do we do the index? We do the index. Oh my god, index poses QI get index position. There's so much deferring. Write opcode. Check if pixels exist in one of the pixel hash buffers. In one of them? What do you mean in one of them? And why 4? What the hell is pixel? Ugh. Channels. Okay, you say 4. Okay. Whatever. So it looks like, yeah, you just check whether it's at the exact index. I guess we'll find out very quickly if this is wrong as well. But so if seen pixels at this hash function, which I can I just copy this? Yeah. Okay. Oh, and then I have to check if they're the same. I see. I should probably write a quick comparison function. If same pixel if yeah, I guess if same pixel, you know, current pixel, rev pixel, and then do that. and then just make a, this is a little weird here, but hey, I don't care. Same pixel, and it takes 2 pixels. Can you please get there? Thank you. Pixel, pixel 1, pixel 2. And sure, can you please do what say I do? Yes. Pixel 1 dot red, pixel 2 dot red. And I'm gonna return this in a giant thing here. Pixel 1 dot green equals pixel. Ooh. I did not know, like this font had a specific triple equal sort of sign. And pixel 1 dot blue equals pixel 2 dot blue. And pixel 1 dot alpha equals pixel 2 dot alpha. Okay. Yeah. So just literally that. So we can say if they are the same pixel, blah, blah, blah. And if we're at index, hello, what are all these LSP issues today? Oh yeah, it's meh. So if same pixel, seen pixels at this, hello, and sort of crpixel. But then the question is, yeah, they must be like let's just make them is crpixel dot red, and then G is green, and then B is blue, and then A is alpha. Right? So if they are the same pixel, or I guess return, right? I can just do this. Because we check if the pixel that, it can't go anywhere else but that index if it's been seen before, right? And if it's not been replaced. So, and if they are the same index, then I do just want to write that index. And this makes it really easy for the decoder. So we're here. Find index. It's annoying that I have to do all this twice. But yes. I guess I have to do all this twice. We'll see if this becomes like annoyingly slow, and we'll kind of speed it up. But I'm doing the diff twice, and so am I doing the other one twice, and like, maybe I should just store these in the beginning, right? So before I even check, I just store these all locally and not make them functions. Except this same pixel can be a function, right? But the other ones, I just store these right here, and then check QI opt if can just become this. Whoops, no. But now I have to pass all these then. It becomes doubly annoying as well. And just at the end of the day, I don't know what's more elegant. But definitely doing these here like that is helpful, because we just have them. And they are the same anyway. So dr, dg, db. So u and it, dr, dg, db. And then, yeah, like at this point, I don't know, man. Not the most elegant solution I've ever done, but hey. It does save some calculations. So, and then if index, but then we already have the index. So we can just say, let's do it the other way. Let's pass these the other way. And then same for here. Let's pass them at the end. Boop, 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 boop. Go away. And then same for this one. What did we pass? We pass a uint ht index. Yeah, but I don't need this check entirely then. You know what I mean? So I can just say if same pixel, current pixel, and scene pixels at index. So on the index is scene pixels at no, it's not scene pixel. It's yeah, it's that hashing function. So it's just this. But I guess it's for the current one then, right? So current pixel dot green, current pixel dot blue, and current pixel dot alpha. So yeah, I mean, okay. So if check the diff, if same pixel, current pixel, and C pixels at index, then we just write the index. You know, if they are the same pixel, if this is what's there, then yeah. And we got to check for luma. How do we check for luma? What has to be possible? The green channel difference has to be representable in 6 bits. And the other one's in 4 bits from that. So that is definitely like a... So I can just say dg. Oops, other way. Current pixel per pixel dg. And then I say dg, because I already have that. If dg oops. So if dg is bigger than, what is it, 63, right? Because that's 6 bits. And 7 bits would be 64. Otherwise, return that the differences of, oh Lord. Okay, yeah. Uint 8t dr dg. Yeah, here. I'll just sort of copy these, because why not? Hello. Copy, paste, align, and then this needs to be, whoops. Cur pix becomes cur, oops, pixel. And prev pix becomes prev pixel. Oh, and yeah, I need to uint 8t. R, whoops, R becomes red, this becomes blue, this becomes red, this becomes blue, and these all become green. But this is just DG. So return dr dg smaller than, what is 4 bits? 4 bits is 1, 2, 4, 8, 16, right? And db dg smaller than 16. So this should make it. But then, I mean, why not make this? Why not do it here? And then I don't need an entire function for this. You know, it does make it sort of almost unnecessary to have functions here. So if the difference of green is smaller than 64 and dr dg is smaller than 16 and db dg is smaller than 16, right? So we can just make this here. No need for a freaking function for this. It just abstracts it into hell, and I mean, we can actually do this as well. Check UI op diff becomes else if cur pixel dot alpha equals prev pixel at alpha and dr is smaller than, what was it? What was it actually? 3? 4. It must be 4. This is also wrong. Good that I looked at it again. And dr is smaller than 4, and dg is smaller than 4, and db is smaller than 4. So this makes it a lot more, I don't know, legible, I guess. So I have same pixel here, blah, blah, blah. We don't have the run length yet. And then we want to do Luma. How do we do Luma? We want to f-write 2 bytes. Huh, okay. Because we're gonna write, okay, of course. We're gonna write DG here. And then drdg and dbdg as like 1 byte. Okay. And then this is Luma. And this is index, isn't it? Because we got run, diff, index, and then Luma. Do we prefer index over diff? Probably. Maybe not. Who knows? Probably not. So fwrite is, the amount is just before here, so we could actually say 2. But then, yeah, it's just easier to think about this as something bigger than 1 byte. So uint16. Yeah. 2 byte. uint16t 2 byte. 2 byte. And this is, whoa. This is whatever this is, right? Because this would be 128, 256, 512, 1024, 2048, 4096. So 81, oh god, okay, 4096. This becomes 8192. And then we're here, right? Hold on. 256, 512, 1024, 2048, 4096, 8192, and then times 2 times 2. Right, so that is that's 16, and then plus 192 times 2 is almost 400. It's going to be 384. So is that 1984? No, of course not 1984. This is 16,000. So it's going to be 16,384. Is that correct? 16,384 divided by 2 is 8192. Okay. So times 2 and times 2. So yeah, it's going to be 32,768. And hopefully it's correct. That should be correct. It does ring a bell here. So that is this byte. Yes, 32,768. But I guess I could also just make that hexadecimal, right? Because what would it be hexadecimal? A full byte is OXFF. So this is here, right? So this would just be, and then you have 2. So you have 100, 200, 800. And then you go up, right? You have 1,000, 2,000, 8,000, 10,000, 20,000. OX20 in decimal. And hopefully that's the same number. OX20,000 is not the same number. Huh. Am I thinking about this wrong? I guess, can I swap from decimal to, from this, hold on, I can't even think. The hexadecimal. It's just 8,000. What? And then binary, that would be just the 1. I guess I completely skipped over something. Okay. I mean, this is a lot more legible. OX8000. We'll stay there. This is OX8000. But like, how did I get this wrong? Because this is OX1, 2, 4, 8, 10, 20, 40, 80, 100, 200, 400, 800. Of course, 1,000, 2,000, 4,000, 8,000. There we go. That's how you do it. Okay. I should have known that. I definitely should have known that. Okay. Anyways, we want to write, and then we want to write the diff green. So dg offset by a byte. And then or that with dr dg offset by 4, and then or that with db dg. And that makes the most sense to me. And then we just write this, but then the size is wrong, the pointer size. So the size should be 2, and the element still should be 1. And then if all else fails, we write either 3 or 4 bytes. So if channel count equals 4, oops, we hello, write the entire thing here, and then just say RGBA. So it's going to be a uint32t RGBA, and this is going to be 4. Otherwise, and this is in a loop, so we can say continue, right? But we can also just say else. Is this in a loop? I've sort of lost track where we are. Yeah. Okay. So we just print the entire thing, and otherwise we sort of do have uint32t, but it's still just yeah, it's still just RGB, and we only read 3 from it. Or do we write 3 separate bytes? I think is the easier one. We can just write from data. We increment the data pointer anyways. So we just write size of 1, 3, 3, and then just read from data. We have size of 1, 4, and then not equals 4. And this is RGB, and then this is RGBA. But then we also need to write the tags, right? So we need to write 1 byte before that, right? Yeah. Okay. Do I want to? I don't want to make a custom struct call here. uint8t tag equals. So that's just going to be 255 for, no, that's 255 is RGBA. Wait, which is, yeah, that's correct here. So we write the tag, which is just 1 byte, and if that 1 byte fails, failed to write tag, failed to write bytes, failed to write bytes. And we can just do the same here. And the tag is 254. Yeah. Okay. Sort of make this a little prettier here. Delete these. Also, we don't need that. Yeah, we can just write from data. This all makes sense to me, and it's probably a really bad idea to write this many lines of code and not be testing stuff, to be completely honest with you. But sometimes that's the way it goes. Sometimes that's just the way it goes. And we still don't have the run length. But we could verify if we nailed everything else. And then sort of go from there. because the run length is a little more difficult to figure out because we have to store where we were and or where we're going to be and stuff, and like, let's see. So this is unconditionally previous pixel becomes the current pixel becomes the previous pixel, and then we store, whoops, we store whatever we saw in scene pixels. That makes sense. Oh, and then yeah, we need to f right here. I don't think the endianness here matters. EOS is just going to be 1. But we write 8, write 1. Right, that's the size. This, I always forget if the size comes first. The size does come first, and the amount. Field to write EOS tag, and then we just say at EOS. So end of stream. Yeah. Okay. That makes the most sense to me. We calculate all these anyway. Maybe it'd be easier if we didn't. I'm saying it would be a lot faster if we didn't. But we need to calculate the index anyway. Right, so we can just do this. Because we have it. And why calculate it twice, you know what I mean? And these others are like trivial. Doesn't really fucking matter. Okay. Let's try and test this after we make the run length. So, okay. I don't know what I want to do less. Actually do this, or, you know, verify if it all works. Also, let's change these to be the constant. So 192 is like, I know, but 192 is a weird tag, right? Because it's 128 plus 64, so that's actually probably easier to read like this as the run tag. But this I'm gonna change as, this is the diff tag. And this is going to be OX1, 2, 4, 8, 10, 20, 40. So OX40, I could have told you that actually. And I'm going to change the order of these. So DG, whoops, DG2 or DB, and that's the end. So this is actually the order in which it's sort of displayed, you know. So this tag is very to the left, and then this is sort of the order. That makes the most sense to me. Same here. And then sure, that's fine. So 255 is just OXFF, right? OXFF in, and just to make sure I'm not fucking crazy, it's what? Yeah, it's always the max. So it's 255. That's like, what am I reading? I'm reading a calculation. It's not that deep. And this should be OXF A. E. All right. That makes the most sense. And we're checking for 11, 44, 11, 33. Just so we're not checking 11, anything wrong, 11, 11. Okay. We should be good. So I think we need a while loop here. Right? But then we need to advance the data pointer and then put it back. So let's say unat start pause or run start is just going to be data. And that is correct. So let's not advance the data pointer. Let's just advance the run start pointer. Yeah. So while, or I guess let's make it a for loop. And then we can just move this in here. Data, plus run start. Oops. And then we need to check for the current pixel, right? Ugh. We need to sort of do this again. They're not when they're not the same pixel, right? Current pixel, next pixel. And so currently the next pixel is going to just be I'm going to just do this the convoluted way. Oh, pixel, next pixel, next pixel dot. We can initialize it in here, right? Why not? Or do we do 0, 0? Yeah, I think we do 0, 0 to 55. And then we just do the same thing as here. But then these become +4 each, right? This becomes data +5, this becomes data +6. And then this becomes data +7, and then, whoops. Current pixel becomes next pixel. And this should be fine. It should be, we could technically crash here if we're checking on the very last pixel, right? So, we'll see. Which FMT is this? Which format? I'm not sure what format specifically you're referring to, modes there, but I'll gladly elaborate. If you're thinking about the code formatting, that's just me. Oh, you mean image format? I'm sorry. I'm so very dug into this image format. QOI. Very simple. This is the entire spec. Very, very simple. Like PNG, but dumbed down. So I wrote a decoder already, and I'm writing an encoder now. And it's really not that much. I'm just very, very concentrated on this right now, because it's the run length encoding is sort of the most difficult thing to think about. So that can show you like how simple the format even is, right? Let's just save. Yeah, let's just save the OG pointer here outside of the loop, so we don't make any mistakes. And then these become -4 again, right? So we want +2, +3, +2, +3, and this is not +3, this is +1. And then we're just gonna increment data once. If data, or I guess, or do we need to, if we want to do that, we need to increment x as well. right? So we don't need to do any of this data nonsense. We can just check for, yeah, put that back. And so if current pixel and previous pixel are the same pixel, then we want to start a run. We say the run length is 0 to begin with. And then to check the next pixel, we need to make sure that we're not reading past the end of the data. So just check for x, no? If x plus 1 bigger than, you know, what is it, width? No. If wherever we currently are, so if y, hello, y times x plus 1 bigger than width times height, then we want to exit here, I guess break. Do we just break? This is the end of, reading past the end of the image. I guess what we have to do is go to the go to EOS, end of stream, and then we just make this the end of the stream, and hopefully, yeah, you can just do this. I don't know, it really doesn't like go-tos, like declarations after go-tos, but that's probably like a scope issue. So if y times x plus 1, which is 1 more than we currently are, yeah, okay. So this is just so we don't read garbage data, and then we need to do the same thing here actually when we're reading, because this is not getting checked in the meantime, right? But then we need to increment data and channel count accordingly whenever we do. So if the very next pixel, no, but do we just want to write a run length of 1 if this is the case. But then I can probably simplify this whole thing, right? I'm trying to think about this. What if we make this whole thing in here, right? And then these all become -4 again, and I'm sorry to like be jumping around so much here. But let's just initialize next pixel as current pixel. Right? If same pixel, like, because we already have a run length of 1, that's the minimum. We already arrived at the conclusion that the current is the same as the previous. Right? Oops. So then we check for current pixel being next pixel, and this will be true in the beginning. Plus run start, but then we also want to plus run length. I guess I don't know what's more legible. I think we increment run length and we increment data. We don't increment data, we say data plus equals channel count, and then we increment x, right? Do we increment x, or do we just do, I think I had the same thing when decoding. The big question is, do we, while we are writing the sort of run of the run length, do we keep continually increasing the X already? Or do we wait until it's finished and then see how long was the run? Let's say it was from here to here, and then we just take the size of this and increment X by that. And I think that is the easier solution. I think that's how I did it. So to do get run length can't be bigger than 62. Increment X and or Y by the appropriate run length amounts and shit. I think this is easier because we need to check whether we're like at the end of a row anyways, and it's much easier to do that when you just have the run length in total. But we just advanced data and we need to make sure that we're not reading garbage. So if how do we make sure we're not reading garbage? Lord, this is annoying here, but I guess I guess we want to increment X, or, you know, if plus plus X equals or bigger than width, then we want to say if this is bigger than height, then we break. I'm pretty sure this is how I did it back then. Hello, dude. My typing game is so weak today. Anyways, so this will increase them, right? I think this is what we're gonna do. Just okay, yeah. So we depend on width and height here for checking whether we're still in the correct place. And then if none of those are true, we increment run length and we can safely increment data. So this just makes sure we don't read from data that is, you know, sort of arbitrary and segfault. And then we need to reset, or I guess increment the pointer. But then we don't need to increment X and Y anymore. Please ensure there's a check for maximum run length. Yeah, that's what I'm doing. I was sort of thinking about the general loop first. Yeah, you are correct. I should check for that here actually. If run length would be bigger than 62, then we break as well. So then we have the correct run length. We don't need to increment X and Y because we're continually incrementing them. Now I'm just afraid that this thing will be off by a 1 because we start at 1 because we've already established current pixel is the previous pixel. So that's run length of 1. And for each time that we go through here and the current pixel is the next pixel. No, we should start at 0 because this loop will already go through once with no issues. Right, because same pixel is the next pixel. Is it? No, I think it'll go like this. I put it in the for loop next to the same pixel. Yeah. I mean, all of these could go there though. So I'm okay with having all my checks at the end. If anything, I would put I'll put the data incrementing here. Whoops. I'm just thinking if this is going to be off by 1, right? So let's say we have a couple. Let's just think about this. Let's say we have a pixel and the values are like A, B. So this would technically be a run of 1 when we get to here, right? So let's make this a comment so it doesn't complain. Because we hit this, and then we're right here. And so this is true. Current pixel is the same as previous pixel. A is the same as A. And so we set next pixel, current pixel, and pref pixel are currently exactly the same. And data is currently right here. So we say, no, we say while they're the same pixel. I don't know why it's not. Yes. So we set run start data, which I don't know why. Okay, let's think about this in a sec here. Current pixel, this will be true. And then we increment run start. Why? I don't need to do that. I think the reason why I did this is because as soon as this check becomes incorrect, we should just get rid of data here. We should just be checking for run start. So data run start. Oops. Let me make this global. So reason why is because as soon as this becomes incorrect, we're losing 1 pixel. Because we've sort of already incremented data, or haven't we? No, we haven't. Ugh, this is so annoying to think about. Which is why I should probably just be testing it. But we don't need this, because as soon as this becomes incorrect, we're always just checking the next one, right? So we're saying next pixel red. We're always checking B, but our pointer is still at A. And so let's say B is not different, right? So the run length is already 1, so we want to write that. And 1 should be the result at the end. So let's see. Next pixel red is just going to be these are going to be the values. X and Y and run length are fine. And then we come to here, and then our pointer is here. But then at the end, will it get incremented? Oh shit. I think by the outer loop, it will get incremented as well. I think, yeah. I think the safer is not to use the data pointer, but the run pointer. Because this will run through, and then over here, data will get incremented, right? But is that correct? I'm having a hard time thinking about this, but this sort of seems like the worst way to do this. Yeah, I don't know why it was plus run start to begin with. That's just flat out wrong. And then whoops, and then let's say here. Because we copy data, and then we use run start as our little thing, and then we're done. And then we want to say data equals run start, which is incorrect. It shouldn't be called run start. It should be called run pixel or something, because it's not just the start, it's the running counter, right? To do, maybe this is off by 1. Whoops. And this is going to be out of scope. So this actually needs to be here somewhere. And I'll set it at the very beginning. Yeah. So let's make this a lookup. We need to verify that this is not off by 1, because my suspicion is it will be. So we say for nothing in the beginning, and then same pixel, blah blah blah. 62 is the max, so that is correct. This should be fine. And then we have the run length, right? And we say we want to save it as such, right? So 192 or the run length, and this will never overflow into these bits because it's smaller than 62, which is smaller than 64. And then we write it. And to be honest, this is sort of it. Unless I've made mistakes, which I most certainly have. Because you never just write 162 lines of code and all of them are correct. doesn't work. So let's see, we need to go into, let's say, oh Lord, what is all this? Oh, it's because I was testing. Oh, okay. So we use image serve load. We want to use image serve right now as well. If not, else we have it loaded and then we just free it. We want to now image serve write, I guess, write file. And we want to say assets tux reconstructed. And I'm not even exporting this function. Image serve write. Yeah, I need to export these both into the header. And here's load, and I want to say write, so extern. And there's also going to be write pointer, but write pointer has a different signature. It just uses these. Right, so yeah, okay. So as soon as we verify that write file is correct, we can try to write file your pointer. Oh yeah, let's go back, and I don't think I said the extern here. Oh, I did. What's wrong then? Oh, it's because it's void. It doesn't return anything yet, but maybe I should return error codes and shit. Maybe return error codes. I probably should. All right, so what are the chances that I am just correct? My guess is it's going to look absolutely horrible. So we need to write file of, I can just do this, the path, the data, so QOI or GBA, right? That's already a pointer. And then what else? The width, I guess expected width, yeah. Or no, so width, height, format channels, bit depth. So format channels, bit depth. How do I get these? I just say format? No. Yeah, it's the file format, isn't it? So I want to use QOI again, because yeah, I have to specify what I want to write as an image serve channels. Let's say RGBA. This, okay, I need to, let's verify that the format actually just saves as that format, not reads. Because this is something I was thinking about, like the thing that I'm passing is the format that I want to save as. And actually I need to know the format of the original. So I need both. And let's say bit depth of 8. So we won't like pay attention to the thing very much here. And then I guess we run. File format is not supported. Right. Why? Format is not, where are these? If file format, find format of path. But find format should find QOI here. Okay, this is a little interesting. So find format should return this because it's QOI. And this is just 0. Why? So we say file format is UNAT. Oh, because we write to format. Bug. Path assets tux reconstructed to QI is not valid. Well, it's path not. I don't think we need to. So for some reason I'm verifying the path, but like I don't need to do that because I'm writing to that path and it doesn't need to exist, right? QI only supports channel counts of 3 or 4, got 0. Counts of... Why are we here? Because we're passing the channel count to write QOI. And we're getting that from here, which is write file, and we say channels. We say image serve channels or GBA. Oh, no, because this needs to be the channel count. Yeah. Okay. Let's just make this 4 for now. I'll think about the sort of API stuff later. Invalid color channels. If channels are bigger than image serve channel max. Yeah, this is just incorrect. Right? Because the format is the file format. Is it not? No, the format is the... Oh, Lord. This is so confusing. Just a wording. This is the image format. Right? This is the image format. And this is the channel count. So now it's much more legible. Such a whack-a-mole experience? Yeah, sometimes it's like that. I kind of liked it though. But now we definitely have image format and file format are different, right? So if channel count, no, you know what? I think the intended API is to say channels. And then pass this. Oof. I'm just gonna pass it as channels, not channel count. And in here, I'm gonna decode that, right? So if I'm gonna make this a different, right? So this is just gonna be channels, but then I want something called channel count, right? So channels, let's say uint8t channel count equals 3, otherwise 4, or 4, yeah, let's say this. And so it's either channels. Okay, this is so confusing. Big Smoke here. Hey, LBHA222. How you doing? Why the burner account? So image serve channels. Let's say RGBA or BGRA, right? So channels equals image serve. Oh, we got RGBA. Let's check for BGRA. And if that's true, then we want 4. If that's incorrect, then we want 3. So we have the channel count. We should be good now, right? So we pass it all. We pass it as channels. We never pass it as channel count. And then the image format is the image format, right? And then this is the file format, which we don't pass because the path already has that info. And then this is also just image format, just so it's more clear. No, this is what the fuck? This is channels. This is the channels. Right? Look. And then what the fuck was the other one for? Why was I passing format and channels? They were the same thing. Guys, name your variables correctly. And why am I passing image format here? I don't need both image format and channels. Aha, because this is not image format. Aha. This is fucking file format. Yes, okay, okay. Write file format. And the other one is read file format, right? So because we have two different, we potentially have, we're reading a PNG, saving as a QOI, because you can use this to convert. Okay, this makes a lot more sense. So to write QOI, we actually just want to pass the write file format, or I guess channels, and then at the end, the write file format. And let's make the same here. Sort of, this is what this takes, right? So we go to, whoops, here, and we say, boom, that's the signature. And this will have to be the same thing? Yes. This will have to be the same thing. So we also want int write file format. Oh, okay. Jesus Christ. And then write QI also needs it, right? So uint write file format. Okay. Wait, actually? No, we don't. Why would we need to pass it? We already know. We want to write as QOI. We're here. There's gonna be no other format. So there, that's it. Unknown format, to do unknown format not supported. Okay, why? This truly is just whack-a-mole. And we can sort of just do this, get rid of that. To do unknown format. It shouldn't be to do. To do yeah, here. That shouldn't be to do either. But if we switch on the write file format, no, we switch on the read file format, right? No, we want to write. Image serve file QOI. So past image serve write file. Write file. We want to actually see the call, which is the channels, bit depth, and channels, bit depth, and write file format at the end. Channels, bit depth, and image serve file QOI. And this needs to be image serve channels, I guess RGBA. And those are the read channels, though. Ooh. Okay, I guess we'll figure that out. Failed to write header. Wow. All right. Well. So, what? We have QOIF, and then we have 0. It's writing, is it writing the null term? What? So this is a 0. Is that same 0 here? Failed to write header. Why are we here? Size of header. Size n, because it's the other way around. because my right call is incorrect. Did this... It went through, which doesn't mean... Oops. It's 990 bytes. I don't have a good feeling about this. But if we sort of hex dump... Yeah, that does not look good. Yeah, that doesn't look good. Ah, error opening image. Okay. It's just wrong. It's weird. But I guess, I mean, I guess the ultimate test, right, is we sort of write this file and then we open it up again, right? Let's just say this, and then we don't need this whole else, right? Whoops. Yeah, we can just do this. And then here. And then we can return -2 here. So it's QYBGRA. Let's say RGBA. Yeah. And then we want to say literally this again. Literally this entire thing again. But we want to say reconstructed. Well, first of all, we want to free this. And then, yeah, just read it again. Reconstructed. Yeah. Yes, okay. So let's return return -2, return -3, and then like return -4 down here or something. And so that should at least give us a good indication. Oh, segfault, malloc. What? I guess, okay, let's run debug, compile only. And now I can try out GF2. Build debug. Oops. Hello? What? Oh, it's bin. Bin debug image div test. So what? I start? How do I start? The executable path is invalid. What? It's not. I can't just call GF2. I have to like path executable. Oh my god. Ask GDB for working directory. No. Okay. Well, path executable. It's gonna be a fucking long ass goddamn path. But I guess you could save it as a project. River 2D map edit vendor river to, it's like super nested vendor image surf bin debug image surf test. There you go. Start. Oh my god, it found it. Okay. So we just run it, and we have in libc. Can I not backtrace? Okay, and load QOI. What the fuck? But we've written correctly, I guess. Well, you know, we've definitely not written correctly. Oh, I guess I should just do there. But like, okay, what's the easiest way to verify what operation I'm even failing on? I think the easiest is to sort of make a test image that's way smaller. But my question is, shouldn't the F writes be sort of failing? Because none of them really do, right? They just, yeah, they just don't fail. So if there's no return, there's no way to return from here. Oh, There's no early return. Unless, no, this should just break out of this loop. That shouldn't do anything. There's no early return without an error message. All of these returns have an error message. So what is going on? And we're not crashing inside write QOI either. So should I sort of just step through maybe? Because what do? We set data to run pixel after we're done running. What's wrong with that? These are both pointers. It's not like we set data to something bogus, do we? Could we be doing that? We set data to run pixel. That's it. These are both pointers, and we increment run pixel by channel count. Huh. Because I have sort of a suspicion that it's here. The other ones don't do anything crazy, right? We just increment data by channel count. We increment X and Y and check for height and width. And that's it. So what if... I wonder if it even works if we sort of just... It probably doesn't. Oh, maybe I'm not passing a uint8 pointer somehow? But I swear to God I am. Image search write file, we're passing QRGBA, which is a uint8 pointer, in which we read the entire thing. We pass width, which is not 0, right? So, I mean, I guess we can also just pass expected width and height, but I don't think that'll do anything. It's probably something really stupid, and I need to just slowly take the time to step through it. Yeah. Because we definitely load it. We're past here. So that's not it. We totally just crash here. So we somehow return from writing. Whoops. Okay, I'm confused by something. Can I please go to the goddamn definition? Thank you. So we return. But here we don't return any error codes, right? So we might just be, we should be returning some error codes. uint8t, let's say, do we have errors? So just -1, -2, -3, -4, -5, -6, just so we know what we're getting, like where we're even returning. But I mean, the printf should not be getting, you know, ignored either. Return -11 and then just return 0 at the end. That should do it. And then we of course need to go into the test file and sort of do it there as well. So if yeah, if this is non-zero, whoops, uint8t result if result return result. Just a very simple way of making sure that we return early if now it's telling me it's corrupted. But now it's sort of not. But so this means we've loaded the entire thing, got 255, expected 113. What? Oh, I see. No, why not make this? Got nothing, expected Q. There we go. Okay, so why do we have nothing? Write QOI. We're saying header is initialized as 0, and then we just set these. Reserve F write header. And how is the header organized? The header is just magic, then width, and then height, and then channel count, and then cutoff space. Oh, wait, is this the size of again? Size, and then how many? Size, and then how many? So that is actually correct. Yeah, but why are we writing that 0? Why are we writing that 0 here somewhere? I don't think this is the very smartest way to write the header. So maybe I don't think I'm gonna. Sure, it's char, isn't it? I don't know. This is so dumb. But let's before we write the header, we just want to write 4 bytes. So size 1 times 4 failed to write. Oops. Magic bytes. Sure, let's also return a -2. So that should be okay. Got nothing, expected Q. Still. And if we hex dump, so let's if we just remove this guy again and just run it again, we still, okay, we're still writing the file. We're exactly writing 990 bytes, which is really interesting. Something is going very wrong. So assets tux reconstructed. So yeah, what the fuck? Got. I guess yeah, maybe that's why I had these. So got 255, expected 113. How? So 113 is Q. Why are we writing 255 there? That's the very first thing. Because the same thing was happening before. These are all chars. So what's wrong with that? These are chars, right? So it's QOIF. So this should be 113. How in the hell are we writing 255? Failed to magic bytes, failed to write. But see, they don't fail. How in the hell are we ever writing 255? Because the header is width, height, channel count, color space. Are these here somewhere? Okay, I'm gonna see. Well, first of all, I'll sort of make a... Whoops. Is that not? Okay. Yeah, I actually should ignore that. So reconstructed. Doesn't matter. Whatever it is, I'm gonna ignore that. So update, git ignore, git ignore. And then I want to try writing and loading written image. Ooh. Yeah, and then, oops, update definitions. That's fine. That's completely fine. So what do I want to do? Let me hex dump this thing. And now it's 7,900. This is like, is this random? It's random. Why is whatever we get, so this is always 0630, 0630, 0780. What in the fucking world? 0630, 0780 is consistent, right? But the other ones aren't. And 4 is also consistent. 4 is the channel count, so that makes sense. But whatever this is, isn't. And then 0. So what it should actually be, right, is it should be so QOIF, and then width and height, which are actually consistent, but I don't think that's right at all. Four bytes is this. So let's say width and height, and then channels 0 and color space is 4 for some reason. Why is the channels maybe this header thing wasn't the best idea. So header.channel count equals channel count, header color space equals 0. That can't be it, right? This is so interesting. Surely that can't be it, right? It's not. This is just Garbo. Why is there Garbo in the beginning always? And you say you got 255? This is that's what. Oh my god. It always says it got 255. But because got. Oops. It's the other one. Right here. Fget C. So byte is an int. This is weird. Expected, and let's just say I wanted that. Got -1. Why is it always writing -1? I mean, that makes sense. That would be 255 then, but like, what the fuck? How is it reading -1 even? Like, what? And this is just all... Is this also Garbo? No, this is definitely... Okay, also that's wrong. So we know for sure that this is wrong now. It is... So... Let's say EOS 0 is just, you know, hex 0, 7... And then we want to do the same exact thing. I guess I could make this. Make this a 1, make this a 1, and then make this a 1. And then just, yeah, I guess -12. So that's also not correct now. This needs to be 1, 2, 3, 4, 5, 6, 7. And the 8 needs to be a 1. Oh, because I'm also just writing. I see the error. Oops. I see the error. There we go. That's also not correct. What the fuck? 1, 2, 3. Oh, because, okay, the bytes are swapped, right? Aren't they? Or am I crazy? Like, this is the lower and that's the higher byte. So this should be hex 87. And this is the lower and that's... So this is the lower and that's the higher. So the order is also swapped. In hex, I guess. So hex 360 in decimal. I mean, I could, you know. What am I expecting? Expected. I'm expecting 1584 in 1920. So 360. So 0630. What about 306? I mean, that also doesn't make sense. 30. So 3006 is also. How does this make any sense? I'm a little weird. So 3006. What should it be? Let's do it the other way. From decimal to hexadecimal, 1584 should be 630. So this is just 1 byte. What? 2 bytes. But 4 actually then. How does this read 630 and this reads 4? I'm so confused. So, okay. Yeah, and then, I mean, you know, 1920 will be 780. So these are actually written right. But I don't know if perfectly correctly. This is just okay. The fact that the beginning of this is always Garbo is just weird. Question is, can I just write text? Probably. I am using the new mic. How do you like it? Because I think it sounds amazing. If I just... No. I also can't do that. And is it still garbage? It's not garbage anymore. It's always consistent. Clean? I really don't want to work today. I totally get that, man. I do, man. DRG Season 6 and Neo 3? Damn. Wasn't Neo 3 demo yesterday? Okay. Well, as little as this makes sense, it is now at least not always garbled. Let's just make sure this wasn't a fluke and we're still even getting it. We're still getting it. It's the same shit, but like... Okay. F right. So we want to say size of 1. No, size. Yeah, size of 1, 4 elements. So that's correct. Failed to write magic bytes. Yeah, I'm just gonna do it like this. And then we don't need this. And then probably I'm gonna do the other ones as well, just by hand. The demo apparently has co-op enabled too, so I'm gonna try that with Rappo or Lee. Damn, nice. I played it for about an hour before bed. I was playing Terraria 1.4.5 with my brother. 1.4.5 sounds really old. Or is that not very old? No, Terraria 1.0 was like recently. Like fairly recently, wasn't it? Or was it Final Patch? I don't remember anymore. I sort of lose track of these things. It came out this week. I don't know, 1.4.5 just sounds like such a low number, but they have been very low with their versioning, I know. I'm just very confused with all this width, height. The struct probably kills things, right? So I'm not going to do that. I'm not going to write the header. I'm going to write each of these individually. So I'm going to write width, or I guess at width. And these are, that's also 4? Yeah, it should also be 4. Yep, okay. Failed to write width. I'm gonna do the same for height, and so on and so forth, because this is probably just safer. Even though I'm already failing at like writing the magic bytes. 15 years old, yeah. I know Terraria is like fucking old, but like, you know, Minecraft is like on version 20 bajillion, so it's always curious how people version their shit. So we want to say 1 channel count 1. Failed to write channel count, and then color space. Color space. Oops. And I don't need the header anymore, and we just say I don't know. It is purely informative anyway, so 63780, that still looks correct. And we say color space FF and channel count is 4. So that looks correct. And the very first operation is FF. Right, which is this. It's 255. And then red, green, blue, alpha. So I should make sure that this is correct. Which I will in a second when I find out why it's writing -1 to Q. What the fuck? And it's always doing that. Oh, also, so I probably should, if file assets sucks. Oh no, probably for written in reconstructed. I think I can wildcard match on both sides. I'm not sure. If sort of if not file written, and I also need to evaluate it here. Then continue. Right, so this way if it finds none, then it just continues, but otherwise we can run it and we have something, we have a reconstructed, and if we clean and we do dir assets again, it's still there because that didn't work. Cool. So I'm guessing it's the wildcard matching. Oh Lord. I'm just gonna make this. So we got dir assets, and then we clean, and then it's still there. Reconstructed. What? Oh, it's because I see why. It's because we're not in that folder. So push D, and then we want dev null. We want pop D dev null. We want push D to assets. Yes, that actually does work. So we have it, and now we don't. Okay, that's great. Remove written images when cleaning. Nice. Yeah. Clean up header writing. But this is just so weird. QIF. I can just search for this. Yeah. So I'm gonna write a fix me here. Fix me. Not writing the header correctly. I think what I can just do, I don't know why I didn't think of this earlier, is just hex dump this. And then if I scroll far enough up, and I'm seeing now that it's a lot of scrolling, can I page up, page down? I cannot page up, page down. So I will have to do this with the mouse. I should probably just inspect it in a text editor, Jesus Christ. Or, ideally, just pipe this into less. Here, so 6F71, 6669, 0000 3006. This is just wrong. The way, yeah, this is exactly what I was expecting, right? So this is 780, but because so the byte orders are swapped. That's why 6F71, and we're getting 6F71, 6669, that's correct. What? And why are you failing here? And why is it saying it? What? So 6F716669, that's correct. 6F716669. What? Then why is it saying it's fucking corrupted? But then 00003006 is not correct because we get the, yeah, 3006, these should be swapped. Oh my lord. Okay. Well, I'm just gonna finish writing this and sort of say, so header, so the DDDD width and height are endianness incorrect. Write byte by byte instead. Yeah, so that's about that. And the color space is like, I don't care about that right now because that has nothing to do with the parsing. But I think I'll sort of leave it here. I have to do some calls still to do some adult stuff and live my life. But yeah, I hope everyone that watched learned a little bit or had fun hanging out, and I'll definitely be working on this and verifying that everything works, but I'm glad that we got everything sort of out of the way and got the first draft of everything. So that was really cool. So yeah, see you guys in the next one.